Welcome viewers, this is tutorial part 2 for pile foundation design with pile cap in CSI ETABS program. This tutorial part focuses mainly on two basic points. The first point, how to assign soil properties. We are going to tell ETABS program how the real soil behaves on piles that may be vertically or horizontally. And the second point, complete analysis, design and detailing. Watch up to the end to master pile foundation design. Now it's a time for subscribe this channel to get next update free. Like this video, support us, and finally drop any comment, maybe your question or suggestion for next. Thank you family for your support. Let's start today's tutorial. Let's back to the first base point, that is assigning all the soil properties. So let's cancel this window and hide all the extrude views. So go back to the plan, that is the pile cap location. From this, let's go to define all the vertical and horizontal spring. That is all about the soil stiffness or soil property. I will tell all this in detail. First, let's go to draw all the developed elevation for this pile group to simplify our work. So let's go to the draw menu here. From this, draw developed elevation definition. From this, let's make it okay. So let's draw starting from this point to this point. This, and this. After that, click on it. This is all about the developed elevation for the first pile group at a, 1. So let's select the top of the pile and the bottom of the pile to assign all the vertical springs. Let's go to the assign menu here. From this joint spring, let's modify or show definition here. Add new property. Property name, let's name it as KV. That is the vertical spring. The vertical spring is nothing but it is the stiffness of soil to resist the vertical movements of pile both in X and Y direction. Let's define all the value based on the Excel template sheet that we are going to define before in tutorial part 1. So this is the Excel template sheet. From this, the vertical spring KV that is defined as that of pile capacity divided by the safety factor. You can get all the value of KV or the vertical spring or the vertical stiffness of soil. So from the vertical stiffness of soil, we are going to calculate the horizontal spring based on our building code of standard. That is almost 10%. You can get all these values. KV, that is the vertical spring toward the Z direction. That is 29.66. Let's round it to 30 kilonewton per meter. So let's go to define it on ETABS software. So we are going to use it toward the Z direction since it's vertical stiffness of soil. So let's use 30. After that, make it okay. Click on add a copy of property to define for that of the horizontal spring. So let's name it as KH. That is for the horizontal spring. Let's check its value from Excel template sheet. That is 2.97. Let's round it to 3. Go back to Excel template sheet. So the KH, that is the horizontal stiffness of soil. Let's make it in X and Y direction. So make it 0 here, 3 both in Y and X direction. After that, make it okay. All the vertical joints are selected here. So we're going to define the vertical spring. Apply, make it okay. So all the vertical spring is defined like this. So let's go to define all the horizontal spring. To define the horizontal spring for all these piles, let's use a segment that may be a 1 meter segment, or you can minimize it. The reason for using this 1 meter segment is that to simulate the soil distribution on this pile. Let's divide two segments. So let's use divide frames here. From this, our depth of pile is 12 meters. So let's divide into 12. Make it okay. Let's select all the joints. After that, go to the design menu again. Joint spring. From this, let's select KH. That is the horizontal spring. Make it okay. You can assign and define both the vertical and horizontal spring to all piles like this. That is all about how to define the soil property, that may be the vertical stiffness or the horizontal stiffness, to all piles. So let's proceed to the next step, or the next point. That is all about analysis, design and detailing. But before that, we are going to mesh all the pile caps. So to do this, first let's go to the plan view here from the pile cap location. After that, let's go to the analysis menu from this automatic mesh setting for floors. Let's use 1 meter by 1 meter mesh. Make it okay. Let's go to set display option here. From this, let's check the box that shell analysis mesh. Make it okay. So our mesh looks like this. Go to the analysis menu. Run the analysis. The analysis result is done, so you can go back here and check all the internal reactions. Let's select combination, that is combination 1 for the factored load for footing design. So you can check the maximum moment, the minimum moment, and the shear and so on. So make it okay. This is all about the maximum moment. Let's proceed to the pile cap design. So go to the design. From this, let's select concrete slab design. So let's check the preference or building code standard. You can select any building code standard here. So let's use Euro code. Make it okay. Go back to design again. Concrete slab design. So you can select any load combination here. You can select any story. Let's select PC, that is the pile cap location. So go back again to the design menu, concrete slab design. So let's start our design. Pile cap design is done like this. So let's check all the requirements, that may be the punching shear and all the reinforcement details. So let's go to the design menu again, concrete slab design. So let's check the punching shear. All the punching shear values are coming like this. So for more visualization, let's go to the select menu here. Select properties. From this, let's select all the frames, that is the piles. So our pile is pile 80 plus pile 60. So let's select them. Make it close. Right click here. Show selected object only. Right click here again. Invert visibility of objects. Now all the punching shear value is visible well. All the punching shear value must be less than 1. If not, you can correct it by adding the thickness of this pile cap. So in our case, all the value is less than 1, but in some point it's greater than 1. You can solve it by adding thickness of this pile caps. Let's proceed to the next step. That is all about reinforcement detailing. So to do this, go to the design menu here. From this concrete slab design, or that of pile cap design. After that, display flexural design. So from this, in the design base, we have two choices, that is strip based and finite element based. Most of my video is all about strip based method. So in this tutorial, let's use finite element based. All of you must give attention here. That is direction 1 for top reinforcement and bottom reinforcement, plus direction 2 for top and bottom reinforcement. This direction is nothing but direction 1 mean all about the X direction, and direction 2 is all about the Y direction. Using all this principle, let's go to detail all the reinforcement for one pile cap. So let's change to direction 1 for the bottom reinforcement, that is toward the X direction. Click this box that is impose minimum reinforcements. After that, make it okay. From this, all the reinforcement area is provided at each point, since we are going to use a finite element method. So all the reinforcement at each point is provided like this for all the pile cap group. Using this area of reinforcement, you can calculate all the spacing and diameter plus number of reinforcements. Don't forget to subscribe, like this video, and drop your comment, maybe your question or your suggestion for the next video. This is all about pile foundation design in CSI ETABS software. Next, we are going to design pile foundation within 5 minutes using ProtaStructure software. Have a nice time. Goodbye. See you there.